Hello everyone, good evening. Am I audible? Okay. All right. So let us start with the class today. So give me a second. I shall start presenting my screen. Okay. Who's this? I have an issue. What is this? Okay, Mahesh Reddy. You are saying you have an issue. May I know what it is? Okay, you are saying while opening the recording session, I'm getting you are denied to access. Okay. So that I'll change it today, okay? I'll finish 1 second. Okay, fine. So I think now it must be fine. So we have changed it and you should be fine now, okay? Is it still breaking? Is my voice still breaking? Is it not clear? Okay, let me share my screen. Okay, so I think you should be able to see my screen as well. I have a good internet and my voice should be properly audible. If you people are not able to hear me properly, then maybe you can check with your internet once. Okay, so let us start with today's class. So before we begin, I have a small introductory session for LMS as most of you asked for it. So we are going to start with one small introductory session about your LMS. Okay. So let us begin. The first and the foremost thing is here in case of your LMS, I don't suggest taking an application. Instead, you can start with a website. You can just browse in your website and you can search for this. For in your convenience, I'm putting this link. I'm sharing it to you people. So here is the link. I'm going to add maybe 1 second. Okay, so I have shared the link in your question and answer wherein you should be able to see the link I have shared. Otherwise, if you want, I can paste it here for your convenience. So this is the link for you to log in to the LMS. Now, once you have started with this login page, first you have to provide your mail ID and then the password here. After which you can give a login. So by any chance, if you do not have the login credentials, let's say you have forgotten your password, you don't remember your password, then you can reset your password. So whenever you have to reset your password, you can click on this option called lost password, and you can search by mail address. You can give your mail address here and you can select on search. Now what this does is it looks into the user's mail ID, whoever has been given access to the LMS. If the access is given to that mail ID, you shall be taken to the next step after you press the search. If that mail ID is not being given access to the LMS, then the search button will not take you to the next stage. Now, when you come to this stage, you should click on continue. When you click on this continue, you will get a new link to reset your password in your mail. Okay, so you can check in the spam, you can check in the inbox, you can check in some deleted folder also sometimes, but check that you shall get a mail to reset your password. Now I do remember my password, so I'm going to give my password. So let me give my password here. And after give my password, oh sorry. Okay, so after I give my password, this is how your LMS page looks like. I will have more features than you people because I have got so many tasks to be done here. So I will have more features to be seen than you people, which you should be okay with. Now you can click on the home, and if you click on the home, you shall have a course by the name in microcontrollers internship. So for me, it is like this. You shall see this embedded systems internship course in your home page. Now you can click on it. It has several sections here. Okay, if you scroll down, you can have several sections. You want to jump to any section, there is this open course index. You can click, you can jump into any section here. Otherwise, you can explore from the main sheet here. Okay, now some features if you can observe, the very first feature here is announcement. So if we have any announcement to make, we shall do it here, and you should be able to see that announcement in this platform. When you log in, if there are any announcements we have made, it appears here. All the general news and announcements, for example, there is no class, or class timing has been changed, or is there any test scheduled, all such announcements will be made under this section called announcements. Then there is another section called discussion forum, which you people shall be using. Now, this discussion forum lets you ask anything regarding the internship. Okay, this forum is created to discuss or to clear your technical doubts. Please feel to ask to the questions related to the internship program. Okay, so if you have any questions to be asked, then you can come to this discussion forum and you can add any questions, any topic of discussion. Maybe here you can select add topic of discussion, give the subject, give the entire message and post it in the forum. So if it is anything related to technical, anybody from our technical team will answer to your question. Anything to be answered, we will make sure that your questions are being answered. Okay, that is your general discussion forum. Then if you want, you can have any help required. Have you completed the installation of MPLAB XID, XC8 and PiximLab? If not, you can click on the, here you can select the answer is yes or no. Okay, so you can give that also. Also, are you able to blink toggle the LED? This, all of these both, you shall be using it later. Then under internship recordings, we have provided the links for the sessions we have taken so far. So I've taken one class on C module, which was on Tuesday and another class on Wednesday. So 2 of the links are already being uploaded. And today's link also, once the class gets completed, within another 30 minutes, I will be uploading it under the section of internship recordings. Then once the C module gets completed, you shall have one C programming test. Okay. Under this weekly test, there is a programming test which should be taken by you people. It will be scheduled. It will be announced. Then you can take the test. Then there is C programming resources wherein you can look for some of the slides. You can look for some of the resources. You can see how to set up the C programming environment on Windows. Then you can see some of the assignments here which you are interested to do, and some templates also are there. Okay, you can just open them, you can practice those programs. And there are resources regarding the microcontrollers module also. Okay, how much ever resources are necessary, we have it already put under the microcontrollers resources. Then after that, once microcontroller module is completed, you have a test for it. Then another test to check for your peripherals. Then a few more tests are there. After that, if there is any other workshops we are going to hold, so such workshops links will all be added here. Some quizzes and all are there. Then after that, you have got a presentation to be submitted, an oral presentation to be done on your video. Some guidelines have been provided. You can go through these guidelines and you can make sure to submit the recordings here under project presentation and demo. Okay, so these are the sections. As I said, I can see more options than you people. Some of them are hidden to you people, so you may not see those options, which should be okay. So for you to focus on is your announcements, wherein we make any announcements, then discussion forum. You should start asking questions here in the discussion forum, which we shall be clearing at any cost. If not immediately, we shall make sure that, we will make sure that your questions are answered and your doubts are being clarified. Then any recordings you want to revisit, you want to watch, it is under this recordings, and any resources you want, it is under the C programming resources. Okay, if you have the login credentials, please log in and you can utilize the platform. If you do not have the login credentials, maybe you would have forgotten, then you can give your mail ID, give forgot password. If the mail ID is registered for the course, then you shall receive a link to reset the password. Okay, so that is about how the platform is considered. Do you get this? Okay, so most of you are saying you don't have login credentials. If you do not have, try doing it. Okay, give the mail ID and select lost password and try resetting. It should be possible. Okay, okay, this is Afreen. Ma'am, I have sent a mail about the offer letter, but still we have not received the offer letter. Afreen, as I said, there are thousands of mails to answer in a day, and you should have patience. Do not worry, they will share for sure without any doubt. Okay, so you have to wait until they respond. Okay, there's no option for internship recording. If you have the access, if you have logged in, then of course this section will be there. So you go to your course, select this course, all of these sections will be seen here, which you should be scrolling up to look into these sections. Okay. Now, those who are not able to open those videos, the settings are being changed. We changed it in the evening today. Maybe once today's class gets completed, try opening it again. It has to open for sure. Okay. This is Vignesh asking, what are the skills needed for an embedded system to get a high package placements apart from C and microcontrollers architecture? So Vignesh, here in our institute, for whichever companies come for the placements from for our institute, we majorly focus on few subjects like C++, data structures, Linux internals, and ELARM. So all of them are very much important for a good placement opportunity, which we shall be teaching here in the institute. Okay. How to install MPLab X IDE, Xe8 compilers and PiximLab, that you will be given with one link to install, that is after the C module is completed. So till then you shall not worry about creating the MPLab X IDE and all. It is not necessary. Yeah. Yogan is asking, I got the LMS link, ma'am, but my mail is did not found in the mail in the search, ma'am. If you have got the link, then you shall see the login credentials in that link only. I mean, along with that mail of link, you will also see the login credentials. You can use those login credentials. Viba is asking, ma'am, when I opened that recording video, it came as you don't have the access. Now you can see, Viba, we have made changes. You should be able to see the recordings. Okay. Then, ma'am, which project I have to complete? So the project to be done will be explained once the microcontrollers module is completed. Okay, who's this? Gunashri is asking, I have a doubt. I have doubt, ma'am. After getting the link settings password, then what to do? After you reset the password, again come back to the course link and give your new password to login, and then explore the features. Okay. Uh, then ma'am, these are the assignments which have to be submitted. So everything you can explore, sit freely for some time, explore all the features, download all the resources, and it should be helping you do the operations. And shall we install Turbo C for practicing, or there are better alternative applications? Actually, Lakshmi Chandini, there is application called VS Code that is better compared to that of your Turbo C. Okay. Then Pratisha is asking, ma'am, I haven't attended 2 classes. Can I go through it again by the link you have provided? Yes, Pratisha, for sure. I know which microcontroller we are going to use. It is PIC16F877A. Is it compulsory to record the project's presentation and demo? Yes, it is compulsory because it is considered for your certificates distribution. So you get the certificate only if you completely finish this internship. Okay. Then you don't have to complete the installation of MPLab X IDE now. Please don't worry about it. Keep it aside. Okay, my project will be simulation hardware or software. It is simulation come software, Supriya. Okay, fine. Right. So I shall start with today's topic. So this is it about the orientation of LMS. Okay. So today, please start exploring it. Use the discussion forum for any of your questions. For technical based questions, don't randomly ask how much percentage is needed and all. So it is obviously important that you attend all the classes. At least 95% of the attendance is mandatory. Okay, so we don't give you just because you have registered. So it is very much important you put your efforts also for us to give you any certificates. So it is very much necessary that you attend the internship on a regular basis and also utilize the full benefit of it. Do the works assigned, like doing the project, recording and all. You put your efforts, only then you will be able to get anything from the institute side also. Okay, so that is it. We will begin again. And okay, microcontroller, it is PIC16F877A. Okay, right. So to start with, today we are going to understand something called as operators in C. So operators are nothing but some special symbols which are used to perform some operations. Okay, so if you look at the operators, please remember there are some special symbols. Okay, there are some special symbols used to perform some operations, Okay, so that is nothing but an operator in general. Now, based on the type of input, we have, based on the number of inputs the operator takes, we have two categories. Three categories, in fact. Based on the number of inputs the operator is going to take, we have three categories like a unary operator, binary operator, and ternary operator. Then, based on the operation it does, the operators have many categories. So let me take you through the section here. All of these are based on loops. Coming to the operators, they are the special symbols that is going to instruct the compiler to perform some operation. So all the operators in C does two things. One is to operate on the inputs provided. The other one is to return the value after the operation is performed. So now, based on the operators, we have several types. And as I said, unary, binary, and ternary is the first category of operators. So unary operator is there, then binary operator is there, then ternary operator is there. A unary operator is going to take only one input. A binary operator is going to take two inputs. A ternary operator will be taking three inputs. Apart from this, there is another category based on the type of operation it does. So we have arithmetic operators, which is your addition, subtraction, multiplication, division, and modulus. So these are arithmetic operators. Then we have logical operators, which is nothing but your logical and, there's logical or, there's logical not. And there is relational operators or relative operators. Relational operators, which is nothing but your greater than, your lesser than, greater than or equal to. Then we have lesser than or equal to, lesser than or equal to, then equal to, and not equal to. So these are your relational operators. Then we have our bitwise operators. Bitwise operators are your bitwise and, then we have bitwise or, then we have bitwise not, bitwise complement, then we have bitwise XOR, then we have bitwise complement, we have bitwise right shift, we have bitwise left shift. So these are bitwise operators. Then you have seen obviously the size of operator, which tells how many bytes of memory is allocated for a variable or a data type. So the list keeps increasing. There are many types of operators here in the C programming language. Now, let's say you are given with an expression called x is equal to 10 plus 3 multiplied by 5 divided by 9 modulus of 7, something like this. This is an expression given to you. How are you going to solve this expression? How are you going to solve this expression? What will you be using to solve this expression? Okay, so I think most of you must have been aware of Bodmer's rule, brackets, order of powers, then division, then multiplication, then addition and subtraction. Most of you must have been aware of this Bodmer's rule. Okay, but in case of the C programming language, we will never be using any such rules called as Bodmer's rule. The reason behind that is, in case of the C programming language, an expression can involve anything beyond arithmetic operators also. An expression can have some logical operators, an expression can have some relational operators, an expression can have some bitwise operators also. An expression can involve any operators other than just the arithmetic operators. And because of that reason, solving an expression with Bodmer's rule is never followed here in the system's memory or by the computer. Computers are never going to follow the Bodmer's rule. Then what does it follow is, it actually follows something called as precedence and associativity. Okay, there is something called as precedence and associativity, which you should be getting with the help of a simple statement called man on operator. Okay, now this is an operator table which gives you the list of the operators what your system can perform. So these are the list of the operators what your system can be performing. Whatever you see in the top has the highest rank, and whatever you see in the bottom has the lowest rank. And you should be using this table to solve any of your expression. Okay. Now using this table, please understand the plus and minus you see in the second line, they are not your addition plus and minus. And this is not your multiplication operator. So this is a pointer operator. This is unary plus, this is unary minus. So we say minus 5 plus 15 and all. These are unary operators. Okay, they are not your arithmetic operators. So this is your multiplication, division, modulus, addition and subtraction. Now you have to look at this and tell me which one will have the highest rank. Okay, look at the table here on the left hand side and how will you solve it? Which one has the highest rank between the two? I mean, between all the operators we have, which one has the highest rank? Okay, so if you observe here, multiplication, division and modulus is in one rank, addition and subtraction is in another rank. Okay, multiplication, division and modulus is in one rank, addition and subtraction is in another rank. Now if you see any of the operators having the same rank, then the next thing you have to be looking at is something called as associativity. Okay, we have to take a look at the associativity, which will be right next to it. Okay, here if you observe, you can see the associativity. And the associativity here says right to left. Now between multiplication, division and modulus, sorry, left to right. Between multiplication, division and modulus, Whichever you come across from the left first will be grouped first. So multiplication will be grouped first like this. Then I have division and modulus. So for division, I should choose the input. One input is 9. The other input is output of this expression. Then I should choose it for modulus. One input is 7. The other input is the expression what you have solved. I'm okay if you solve also. Okay. For example, let's say okay, for example, if you say this is my expression, okay, I'm okay if you solve it according to this table. So first I have multiplication, so let me solve this multiplication. Okay, so solving 3 multiplied by 5, so I'm going to get 15. Then I have division here. So division should be solved. The associativity says left to right. When I'm coming from left to right, I came across multiplication first. Then I'm coming across division. 15 divided by 9. It gives you the quotient. The quotient here is 1. Okay. 15 divided by 9, the quotient is 1. So it returns 1. Then I have modulus. So 1 modulus of 7. What happens if 1 is divided by 7? What do you get as a remainder? The remainder will be 1. So it returns 1. Then the value of x will be 11. Okay. Similarly, I'll give you another expression. X is equal to, let's say, 25 minus 12. Then plus 3, then modulus of 4, then divided by 5, multiplied by, or let's say multiplied by 5, divided by 2. Can you tell me what is the output of this? You should make use of this table. If the operators are in the same rank, look at the associativity. If it is left to right, travel from left to right of your expression and solve your expression. So what will be the output? Come on, let's see what is the output. Okay, I can see if some of you saying it as 20, some of you saying it as minus 5, then 26, 23, 10, 12, so many different answers. 15, then 5, 12, 20, 16. 16 is the answer. 20. Okay. I'll repeat for this example. Okay. So let me repeat for this example. Whenever I have to solve this expression, I take a look of precedence and associativity. Okay. I take a look of this table. So I'm going to take a look at this precedence and associativity table. If you look at this line, okay, multiplication, division, modulus has the same rank. Addition, subtraction has another rank. Now, if an expression has multiplication, division, modulus, I should look at the associativity, which is left to right. I should travel from left to right of my expression. Among multiplication, division, and modulus, whichever I come across first should be grouped first. Now I travel from left. So I come across modulus first. So I should be solving that first. I should actually be grouping. But anyways, for your convenience, I will solve. Okay. So when I solve 3 modulus of 4, you are going to use modulus to get the remainder. When you divide 3 by 4, you get the remainder as 3 only. Okay. Next, I have, okay, by mistake, I've taken both multiplication. Anyways, I have multiplication. So I have to, my next stage is between multiplication, addition and subtraction. Multiplication has the highest rank. So I have to do the multiplication. I should do 3 multiplied by 5, which is 15. Then I should also do 15 multiplied by 2, which is 30. Okay. Next, between addition and subtraction, both of them has the same rank. In my expression, I have addition and subtraction having the same rank. So I should take a look at the associativity. I travel from the left of my expression. Whichever I come across first, I'll solve first. So I will do 25 minus 12. So 25 minus 12 is how much? 12, 22, 23, 24, 25, 13. So 13 plus 30, the answer is 43. Okay, so the answer is 43. If you want, let me run this to show you the output. Okay, so here I'll take one online compiler. Okay, this is for C and this one. Okay, so here I am going to take that expression like this. Let's say int x is equal to, this is the expression. Then after that, let me print the value of x here. Percentage d equivalent of x. Okay, I run. Let me choose the language as C. I run, you can see 43 as the output. Okay, so that is how you are going to solve your expression hereafter. I mean, how your system solves. Obviously, it is not with respect to your BODMAS rule. Instead, it takes care of this table called precedence and associativity table. Okay, so precedence and associativity is the one which is used to solve your expression. Okay, then modulus is one operator. This is called as modulus operator, and this modulus is meant to give you the remainder. Okay, basic maths, guys. So when you divide 4 by 3, what do you get as a remainder should be given by your modulus. It is like this. You have 4, you want to divide it by, you have 3, which you want to divide it by 4. So 4 zeros are 0. The remainder is 3 here. Okay, so after this, the remainder is 3 here. So that is what you get as a remainder. That is modulus. Division gives you this part, which is quotient. Modulus gives you this part, which is remainder. Okay, this is something called as quotient, which is given by your division operator. Division. And this is called your remainder. And this is given by your modulus operator, represented by a percentage. Okay, so that is your arithmetic operator. Now look at this another example and tell me what is the output. Oh, sorry, not this. No. Okay, so that is about your arithmetic operator. The next we have is logical operators. Okay, now logical operators are meant to check for multiple conditions. Logical operators, okay, are used to check multiple conditions. Okay, logical operators are used to check for multiple conditions. we have logical AND, which is represented by 2 ampersand. Then we have logical OR, which is represented by 2 pipes. And then we have logical NOT. Okay, we also have logical NOT, which is represented by a pipe. Now the input to the logical operators are in terms of true and false. The output is also in terms of true and false. Okay, so input is true, sorry, this is my first input, let's say input 1. Then you have another input 2. And this is your output. Okay, so if the first input is false and the second input is also false, let's say it is also false, your output is false. Then if the first input is false, your second input is true, even then your output is false. If the first input is true, the second input is false, your output is still a false. And true and with true only gives you true. Okay, so when you're making use of any logical operators like this, and I should have first input to the left of it, input 1, and I should have second input to the right of it, input 2. Okay, now any non-zero value in place of input is treated as true. Any non-zero in place of input, is true. Okay, any non-zero value in place of input is true, and a 0 is treated as false. 0 is false. Okay, that is one point you have to remember. When you are using logical AND, there is one input you write to the left, another input you write to the right of it. So input 1, logical AND with input 2. Or if you take logical OR, the truth table is like this. Okay, if this is your logical OR, then the truth table is, it looks very simple. So in both of these cases, it is true. Okay, so here also the output is true, and here also the output is true. That is logical OR. Now, if you think of logical NOT, it takes only one input and it gives us one output. If the input is false, the output is true. And if the input is true, the output is false. Okay, so that is your logical NOT operator, like this. So always your first input and second input should be given. Similarly, in case of logical OR also, you write your first input and you write a logical OR with your second input. So in place of input, any non-zero value is treated as true and a 0 is treated as false. Now remember one more point, something called as increment operator, which is represented by a plus plus. The increment operator is used to increase the value of a variable by 1. Increase the value of a variable by 1. Okay, increment operator is used to increase the value of the variable by 1. Now we have two types. One is pre-increment, the other one is post-increment. Similar to increment, we have decrement also. Okay, we have pre-increment, we have post-increment. Now what is the differences? You write it like this, it is pre-increment. You write it like this, it is post-increment. Variable's name, before that the operator, it is pre-increment. First variable's name, then the operator, it is post-increment. So we have two types of increment here. One is pre-increment, the other one is post-increment. But both of them are used to increase the value of the variable x by 1. Okay, let's assume you have the value of x as 5. Okay, plus plus x will change the value of x to 6, and x plus plus will also change the value of x to 6. But pre-increment changes the value immediately. Post-increment changes for the next time. Okay, immediately. Post-increment will change for the next time you access. Change will happen in the next statement, not in the same statement. Okay, change will happen in the next statement. Okay, now please listen to this and answer this question. So what will be the output of the program for this case? Only this much. I will copy and maybe I'll put it here. So I have two integer variables called num1 and num2. Num1's initial value is 1, num2 is initial value is 0. Okay. Now what will be the output of this program? Num1 plus plus. Sorry, this I shall give 0 here, not 0. I'll give -1. Okay. So what will be the output of this program? Come on, what do you think is the output of this program? It is logical OR, by the way. What do you think the output of this program is? Okay, so I can see the answers like 0, 1, 0, 1, then continuously 1 to infinite. First of all, infinite is not in this picture, okay, because there is a simple if condition. So the statement if you have written will get either executed for once or it will never get executed. Now, if you consider this example, the value of num1 is initially -1. So when I do num1 plus plus, the value should be updated immediately to the next value. -1 plus 1 will be 0. So num1's value will become 0. Now 0 in place of input is treated to be condition false. So this is false. Then after this, logical OR with num2 plus plus. So num2's initial value is 0. 0 plus plus, please remember, the change will not happen at that stage. The change happens for the next time you access. Okay, because the change happens for the next time you access. So at this stage, it still remains to be 0 and it is condition false. So false or with false will be false. You don't enter into the if condition and nothing is being printed. So that is the difference between pre and post increment. Pre-increment changes the value immediately. Post-increment changes for the next time. So num2 will be updated to 1 for the next time, not to this statement. Now what happens if I write this with 1? What will be the output? If I write this with 1, what will be the output? Okay. So now in this case, the value of num1 is -1. So num1 plus plus will be 0 at at that stage itself, which is false. Logical OR with num2 plus plus. Num2 is 1 plus plus. 1 plus plus will be changed to 2 for the next time. But for this time, it remains 1. 1 is condition true. So true and with true will be, false or with true will be true. You enter into the if condition. I'm printing the value of num1 and num2. So when I print the value of num1 plus of num1, I have already changed it to 0. So 0 is printed. Num2, I did num2 plus plus. So for the next time if I access num2, it should be updated to 2. So 0 and 2 will be printed as the output. Okay, you can see 0 and 2 being printed as the output. Similarly, let me go for AND here. Okay, let's see. Okay, so this is int num1 plus plus. Now, what will be the output? I mean, will you get an if block printed or from the else block? That is my question. And what will be the value of num1 and num2? Will it be an if block printed or will it be an else block? Okay, some of you are saying it as if, some of you are saying it as else. Okay, so if you ask me, let me explain here. First, I'm doing num1 plus plus. So it is 1 plus plus. The value will not change immediately. It should change only for the next time. So now it is 1 only, which is a non-zero value. Hence, the condition is to be treated as true. Logical AND with plus of num2. Num2 is 0. It changes to 1 immediately. So that is also a non-zero value. Hence, it is true. True and with true is true. You enter into the if condition. So num1 is now updated to 2 because of the previous statement. Num1 is now updated to 2. Num2 is 1. So 2 and 1 should be printed. Okay. Num1 is 2 and num2 is 1. This is printed from the if condition. So if you see this, I'm running. You can see from the if condition, num1 is 2 and num2 is 1. Okay. Now, what happens in this case? One last example. What happens here? Okay. So now what do you think happens in this case? Okay, so if you think of this example, okay, I can see most of you answering it as 2 and 1. True, num1 is 1 and num2 is 0, then num1 is 1 and num2 is 1 again, which is true. I have a single if condition. Output is 2 and 1, 2 and 0. Okay. Now there is a small trick in this. Okay. So num1 is 1. Plus of num1 should be 2 at that stage itself. The value of num1 should be updated to 2 at that stage itself, which is condition true. Logical OR with. In the second case, num2's initial value is 0. 0 plus. The value will be considered as 0 here, but for the next time it should be updated to 1. And 0 is false. Anyways, true or with false is true. You enter into the if condition. We are expecting num1 to be 2 and num2 is now updated to 1. But the answer will be 2 and 0. The reason behind that is there is something called as short circuit evaluation. Okay, we have something called as short circuit evaluation, which happens in both logical and in case of logical OR. So in case of logical OR, that is in two pipes, what happens is, if the first input is true, observe, in case of logical OR, if the first input is true, you don't have to check for the second input. You can directly conclude it as true. Okay, if the first input is true, irrespective of the second input, the output is true. This is what happens by all of the smart compilers. Okay, all of our compilers are smart compilers. It tries saving its time. It tries executing the statements faster. So when it comes to the logical OR, when it finds that the first input is true, it will not waste its time in checking what the second input is. It is directly concluding that the output is true. So that happens in logical OR, which is why in this case, if you observe, you shall see a 2 and a 0 printed, because first condition is true. It is not wasting its time to check for the second condition. So you directly say that your output is true and you get this if condition printed. So that happens in logical OR. The same happens in your logical AND also. Okay. This kind of operation happens in logical AND also. Now, how does it happen in logical AND? Please see. If the first input is false, it will not waste its time to check the second input. Whatever is the second input, it will not waste its time to check the second input. It directly concludes the output as false. So that happens in case of logical AND. So please remember in logical OR, okay, if the, I'm writing here, if the first input is true, okay, irrespective of second input, the output is true. Okay, but in case of logical AND, okay, in case of logical AND, please remember, if the first input is false, irrespective of the second input, the output is also false. Irrespective of the second input, the output is false. So that is short circuit evaluation, which happens in logical operators. Whenever you want the systems to get executed faster, if you want your statements to get executed faster, compiler skips certain statements of it to execute the questions faster, to execute the things faster. So that is nothing but your short circuit evaluation. Okay, Yogesh is asking, can we get this journal file anywhere at the end? Yes, I will make sure I'll upload it once the C module gets completed. Okay, so that is about the short circuit evaluation which happens in logical operators. So I spoke about logical operators. These are the operators which are used to check for more than one conditions. Okay, similarly we have a relational operator. Relational operators are used to check the relation between the two values. In this example, what do you think the output is? What is the output in this? What do you think the output is? Equal to is to check if the value is same or not. So what do you think the output of this program is? Okay. It is so obvious that everybody will say it is equal only. Okay. But trust me, the answer to this is not equal. Okay. So I'll take it here and print it. Okay. So here the same question. Okay. It's the same program. I'm going to align it properly like this. One else block. I'm aligning it. Okay. So here, you can look at the message once I execute this code. So I'm going to say okay, let's say I'm going to run this. You can see that the two numbers are not equal. For this question, you get to see that the two numbers are not equal. Now change it. I will change it to 0.5. Okay, I'm changing it to 0.5. Now see the two numbers will be equal. Okay, the two numbers are not equal if I give 0.7. The two numbers are equal if I give 0.5. Now, in short, I will explain it. Okay, it is quite tricky to consider, but I will give you what is the reason behind it. Okay, now the reason behind that is, in short, if you want to remember, if you take a number, you have to represent it in the binary form. Take a fractional number and try representing it in binary. Whether it is 0.7 or you take 1.7 or you take 2.7, 3.7, 13.7, 15.7, anything like this you take. I will take only the fractional part of it. Okay, only this fractional part of it. I want the 0.7 to be represented in binary. So I generally keep multiplying the number by 2 to represent it in binary. So I get 1.4. Then I take only fractional part, multiply it by 2, then 0.8. Then I take the fractional part, multiply it by 2, I get 1.6. I take the fractional part, 0.6 multiplied by 2, I get 1.2. I take the fractional part, 0.2 multiplied by 2, I get 0.4. In fact, I will never get an end to it. I will not get product as 0 anytime. It keeps continuing like this. But take it for 0.5. If it is 0.5 or if it is 0.25 or if it is 15.25, any of this, you will see an end to it. Okay. You will see an end to it. For example, 0.25. So 0.25 multiplied by 2, you will get 0.5. Then you take 0.5 multiplied by 2, you get 1.0. Then you take 0.0 multiplied by 2, you get 0.0. And there is no point in continuing the multiplication. Okay. And you get an end to it. If you see any fractional numbers getting an end to it, then those two numbers will be equal. If the two fractional numbers do not get an end to it, then they are not equal. So that is the simplest way you can remember. So take 1.2. Okay. It will never get an end to it. You will never get an end to it. So you will see they are not equal. Similarly, take 15.25. You get an end to the fractional part. So for that, you will see they are equal. Okay, that is the easiest way, but there is a technical reason behind it. Making you understand the technical reason behind it is not possible. It is not doable now. Okay, so you can just remember it like this. Okay, keep it simple, understand it the easiest way. So when you are trying to multiply a number by 2, you get an end to the numbers. You can see that it is those numbers are equal. You do not see an end to it, they are not equal. I hope you are getting it. Okay. Right. So how to know which has an end? You have to keep multiplying the number by 2. Keep multiplying the number by 2. You will get an end to it. See, I'll repeat again. So any numbers like the 0.7, 1.7, 2.7, 3.7, 15.7, maybe 12.2, then 14 something like 8. So all of these numbers are not going to find an end to it when you multiply the fractional part by 2. See, you take fractional part, take 0.7 multiplied by 2. Keep taking only fractional part of it. Take 0.8 multiplied by 2. You get 1.6. 0.6 multiplied by 2. You get 1.2. 0.2 multiplied by 2. 0.4. You will never get an end to it. So if that is the case, the two numbers can never be equal. But if you find an end to it, for example, 0.5, 0.25, 15.25, then 0.75, 0.625, they all will give an end to it at some point. If you get an end to it, then the numbers will be equal. Okay, so that is about the relational operators. Then we have assignment operators. Assignment operators are used to assign the value from one value to another. So see here, 1 will be assigned to num1. It is an assignment operator. It is not relational. It is assignment. So 1 is assigned to num1 and that 1 is considered for condition. If of 1 is true, so you get this message printed. Okay, that is assignment. So this is also assignment operator. Okay, now how do you solve this expression is? Let me show it here. How do you solve this expression is? This expression will be seen by your compiler as plus equal to will be seen by your compiler as num3 is equal to num3 plus num4. Okay, if it is like this, x plus equal to 5 is returned, it will be seen by your compiler as x is equal to x plus 5. Okay, the same here. Num3 plus equal to is num3 equal to num3 plus num4. That should be solved first. Okay, now when you solve, what happens? Num3 is 1.7, num4 is 1.5. So this will be assigned with 3.2. Okay, 3.2. Now I should solve this expression. Now num3 is being changed to 3.2. Then in place of this, I should take 3.2. Okay. Then again, I have plus equal to. So num2 is equal to num2 plus 3.2. Okay. Num2 is 1. 1 plus 3.2 is 4.2. Now what happens with that is 4.2 means num2 is assigned with 4.2. But what type of value is num2? What type of value is num2? It is an integer value. Now, because it is an integer value, I can only take integral part of it. So only 4 is assigned. Then 4 is taken in place of that. So here it will be seen as num1 is equal to num1 plus 4. Okay, num1 is equal to num1 plus 4. So num1's initial value is 1. 1 plus 4 is 5. So num1 is assigned with 5. You print this, you get 5 printed as an output. So that is how assignment operators are working. So these are very rarely used operators. You don't see it more often. Okay, so you don't see it more often. So they are very rarely used, but yes, you are able to consider this assignment operator also. Next, the most important we have is bitwise operators. Okay, so we have a total of 6 bitwise operators in C. The bitwise operators are going to perform the operations on bits of a number. Okay, bitwise operators are going to perform the operations on bits of a number, which means the number should always be integer. Number should always be integer. Okay, bitwise operators are performing the operations on bits of a number, and the number shall always be integer. Only then bitwise operators can be operating. Now the inputs shall always be integral. The output is also integer. Input can be any integer, output can be any integer. Now, first and the foremost thing, we shall see a bitwise AND. A bitwise AND is represented by a simple ampersand. Now, what this bitwise AND does is, it takes two inputs, input 1, input 2, and one output. Okay. Now, what it does is, the two inputs are in terms of zeros and ones. They are bits. So if the first input is 0 and second input is 0, output is 0. 0 and with 1 is 0. 1 and with 0 is 0. 1 and with 1 is 1. Okay, so that is your bitwise AND. Now let us see how to work on it. Let's assume I have two numbers, num1 with the value 0x45, num2 with the value 0x 97 or 98. If I write a number starting with 0x, what do you mean by that number? In what form is the number? In what form the number is if I write it in 0x? It stands for hexadecimal. Okay. Please remember, you have four types of integers. Okay. There are 4 types of integers. So there is a decimal number, there is a octal number, there is a hexadecimal number, and one last, there is a binary number. So decimal number is saying in terms of base 10. Whatever we speak, it is decimal. Octal is base 8. Hexadecimal is base 16. Binary is base 2. Okay. Now, one advantage of a hexadecimal number is representing it in binary is easy. Every hexadecimal number should be represented in 4 binary digits. Okay. Every hexadecimal number should be represented in 4 binary digits. Can you tell me How to represent 45 in binary then? Every hexadecimal digit should be represented in 4 binary digits. So how do I represent 45 in binary? So I should represent 4 in binary, 5 in binary. 4 in 4 digits, 5 using 4 digits. So it has to be 0s 1 0 0 and 0 0 sorry 0 1 0 1. This is 45 in binary. Similarly, my second number is 98. 9 is 1000, sorry 1001, and 8 is 1000. Luckily here bitwise AND is not suitable. Let me go for 5 here. 7. I'll make 75 and 98. So 7 in binary is 0111 and 0101. Okay. Now I have to perform the AND. When I perform the AND, I'm going to do it in terms of bits. Okay. So with the help of the table, 0 and with 1 is 1. 1 and, sorry. I'm sorry. 0 and with 1 is 0. 1 and with 0 is 0. This is also 0. This is 1. Then 0 and with 1 is 0. 1 and with 0 is 0. This is 0. This is 0. So the output is 0x10. In hexadecimal, the output is 0x10. If you convert it into decimal, this is 0 multiplied by 2 power 0. This is 0 multiplied by 2 power 1. This is 0 multiplied by 2 power 2. This is 2 power 3. This is 2 power 4, which is nothing but 16 in decimal. The result is 16 in decimal. In hexadecimal, it is 0x10. Okay, so that is how you take a number in the hexadecimal format. Can you tell me what happens if my number is 0x 5 6 and your num2 is, let's say num2 is 0x 0x7 4. Yes. So what will be the result if I do num1 and with num2? What will be the result if I do num1 and with num2? Make it fast. You should represent the number in binary, then give me the result. I want the result in hexadecimal. If possible, you can also give me in decimal. What will be the output here? I can say 0x, I can see 0x54, 0x14. Okay, many are saying it is 0x54. Okay, let's see. So first 56 represented in binary, it is hexadecimal. So 5 represented in binary is 0101. 6 represented in binary is 0110. 7 represented in binary is 0111. And 4 represented in binary is 0100. Now I have to perform the AND. When I perform the AND for this, so 0 and with 0 is 0. Then 1 and with 1 is 1. 0, 1. Then 0, 1, 0, 0. So this is going to give me 0x54 in hexadecimal form. Now let us see what happens if I use bitwise OR. Okay. Bitwise OR is represented by a pipe. The truth table for bitwise OR looks like this. Okay, this is bitwise OR. The truth table of bitwise OR is here also it's 1, here also it's 1. Let me give you one simple example. Num1 is 0x 53, and your num2 is 0x a9. So A represents 10, B represents 11, C represents 13, D represents 14, E represents 50. Sorry, A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. That is the maximum. Okay. So now what is num1 or with num2? What do you get? Okay, so here I can see most of you saying it as E9, FB, EB, FB, EB, FB, EB. Okay, so let's see what happens in this case. So first and the foremost thing, here I'm going to represent 53 in binary, which is 0101 and 0011. A is 10. 10 represented in binary is 1010. 9 is 1001. Now I have to perform the OR operation here. So when the OR operation is being performed, 0 OR with 1 will be a 1. Then this is 1, 1, 1. Then 1, 0, 1, 1. So 1, 1, 1, 1 hexadecimal, we call it as F. And 1, 0, 1, 1. So it is 10 plus 1, 11. 11 is B. Okay. 0x FB is the output. Similarly, I'll go for bitwise XOR. Okay. Let me make you do it for bitwise XOR also. So this is for bitwise XOR. Bitwise XOR is represented by a cap. Okay. So the output is like this. Two inputs are same, output is 0. Two inputs are different, the output is 1. So let's assume num1 is 0x some E9 and num2 is 0x 7, 2. Okay. So now what is num1 XOR with num2? What do you get as an output? Num1 XOR with num2. What is the expected output? Nine B. Okay, so most of you are saying it as 9B, but Anjali says 9A. Okay, so first, E and 9 should be represented in binary. So E represented in binary, E stands for 14, which is 1110. 9 is 1001. Then 7 is 0111 and 2 is 0010. So if the inputs are different, the output will be 1. If the inputs are same, output will be 0. So here in this case, I'm doing the inputs are different, so output is 1. Then this is input is same, output is 0, same, different. Then this is 1, inputs are different, same, different, different. Okay, so the output is 0x 1001 is this is 1001 is 9 and 1010 is B. So 0x 9B. So that is bitwise XOR. Next we have is bitwise complement. So bitwise complement is represented by a tilde. It takes only 2 inputs. It takes only 1 input. So there is input 1 and you have an output. So now what your complement does is convert all 0 to 1 and all 1 to 0. So if the input is 0, output will be 1. And if the input is 1, output will be 0. If let's say my number is 0x, number is 0x E2. Okay. What will be complement of number? Okay, so complement will just change the bits from 0 to 1 and 1 to 0. Okay, so I can see most of you seeing it as 1C, 1D, 1D, 1C. So number is E. E is 14. So 1110. 2 is 0010. Complement is 0001 and 1101. Okay, 1101 is 13. So it has to be D. So 0x 1D is your output. Are you able to follow this? Okay. So the next we have is bitwise bitwise left shift. Okay, bitwise left shift. Now left shift means you are going to shift the numbers, bits. You are going to shift the bits of the number to the left for certain number of times. It is represented by 2 lesser than symbols. So you should first give the value a left shift, number of times you want the shift to happen, number of shifts. Let's assume my number is 0x 42. Okay, my number is, or let's say 0x02. Okay, I want to do number left shifted for 2 times. Okay, I want to do number left shifted for 2 times. Now, how do you think this is going to work? This is my number 00000010. I should shift it to the left for 2 times. Okay, so what I'll do is I'll represent it like this so that the shifting is shown properly. So this is my number in 8 bits. Okay, my number 0x02 is being represented here properly. I want to perform the left shift. I want to shift the bits to the left for twice. Okay, so like this once for another time. So this is my number. The number is 0, 0, 0, 0 and 0, 0, 1, 0. Okay. So I want to shift it to the left. So whenever I'm going to shift, my MSB bit is lost. My LSB bit will be filled with 0. In case of left shift, always MSB is lost and LSB is filled with a 0. Okay, like this. So always MSB bit. The first bit is called as MSB bit, which is lost, and your LSB bit is filled with 0. So this bit is lost, and here I'll have 0, 0, 0, 0, 0, 1, 0, and followed by a 0. Now this I shifted for once. I should shift it for another time because the question is to do the left shift for twice. So when I shift it for another time, the operation happens like this. The MSB bit is lost and all of your bits are shifted to the left for one time. So 0, then 1 comes here, then 0 comes here, then 0 comes here. LSB is filled with 0. Can you tell me what is the decimal equivalent of this? This is 2. What is the decimal equivalent of this number? What is the decimal equivalent of this? It is 4. Then what is the decimal equivalent of my next number? This is 4. This is 8. What do you understand from each of this? How are they related to each other? How are they related to each other? You're multiplying it by 2. Okay. So the relationship is you are multiplying it by 2 always. So this is your input, that is 2 multiplied by 2 power 1. So this is your 2 multiplied by 2 power 0. And this is your 2 multiplied by 2 power 2. Okay. So if you say number is right shifted for n times, then the result is, in mathematical form, the result is number multiplied by 2 power n. It is not XOR, it is power, I'm saying. Okay. So when you want to do number right shifted for n times, it means the result is number multiplied by 2 power n. So that is what you see here in the left shift. Similarly, you have right shift also, wherein you can shift your bits to the right. Okay. You can shift your bits to the right. We call it as right shift. But in case of right shift, we have 2 types. Okay. In case of right shift, we have 2 types. 2 types. One is signed right shift. The other one is unsigned right shift. It depends on the type of the value you are dealing with. So we have a signed right shift and an unsigned right shift. Now, if the number is signed, we do signed right shift. Okay. Let's say I write my number as 0x A3. Okay, this is my number 0x A3. So here I take my number as maybe some 8. Okay, I want to do number right shifted for 2 times here. I want to do number right shifted for 2 times here also. Now what happens in the right shift is, it is always the LSB bit is lost. Okay, whenever you do the right shift, the LSB bit is lost. Okay, here let's say in the right shift, LSB is lost. Now, in the signed right shift, MSB is filled with previous MSB. MSB is filled with previous MSB. And in case of unsigned right shift, MSB is filled with 0. Remember this. MSB is filled with 0. Okay. Now what makes the difference? This is my number 0xA3. A is 1, 0, 1, 0 and 3 is 0, 0, 1, 1. So you want to perform the signed right shift. So in the signed right shift, you are going to shift the data to the right for once. MSB is lost. LSB is lost. MSB will have the previous MSB like this. The MSB is retained like this. It is also shifted to the right. Then all of your bits are shifted to the right like this. Okay. So your bits are shifted to the right like this. Your last LSB bit is lost. This bit gets lost. So the same happens here also. Your previous MSB is retained as it is. Your next data is shifted to the right as well. So your MSB is moved to the right. LSB is lost always. Okay. So this bit is lost. So the result here is 1 and all of the data is being shifted to the right for once. Okay. Similarly here, this is 1, 1. And you can see all of your data is shifted to the right. So that is what happens in the right shift. Okay. Similarly, in case of unsigned right shift, MSB is always filled with a 0. So I'm writing a 8 here. So it is 0, 0, 0, 0, 1, 0, 0, 0. So when you perform the right shift, the MSB is always filled with 0 now. Okay. So here I'll have okay. This bit is lost and you're going to add 1, 0 here. All of the bits are shifted to the right. So similarly here, it happens like this. Bits are shifted to the right. LSB bit is lost. MSB bit is filled with 0. Now what do you see from each of this? This one is 2. Sorry, this one is 8. This one is 4. And this one is 2. So if you understand, the result here is whenever I want to do number right shifted for n number of times, the result is number divided by 2 power n. Okay, so that is right shift, what you see here. Do you understand this? Everybody? Okay. Right, fine. So let me stop here for today. So to summarize today, we just took a quick we just took a quick update of how to make use of your LMS platform. And we started with the operators today. We studied arithmetic operators, logical operators, then bitwise operators, relational operators, and also assignment operators. So the rest of the things we shall do it in the next class. Okay. Please remember, no class tomorrow. Okay. Your next class is on Monday. Okay. Please remember this. No class tomorrow. Your next class is on Monday. Okay. So by Monday, you should remember all of this. It is very much important. Any doubts if you have got, then please use the discussion forum to ask your doubts. Do not expect the answer immediately after your doubt is being posted. It takes few minutes, sometimes few more minutes to actually consider it. But whenever we do get the time, we will reply for sure. But use your discussion forum only to ask your technical doubts. Okay. So the next quiz we will be updating. We will give you the announcements. Yes, I will share this notes also. And do not worry, it will be there under the recordings only. Okay. In the recordings only, I will add this notes also. You can utilize it. Okay. Till then, practice all of the programs, explore the LMS, and you should be able to explore more from the LMS. Any technical doubts, please use the discussion forum. So no class tomorrow, your next class is on Monday. Thank you all for attending today's session, and we shall continue the class on Monday. Thank you all. Happy weekend, and please explore LMS, use the discussion forum.